Hello, this is Miss Moore, and today during chemistry we're going to discuss unit conversions, specifically metric conversions. Today's essential question: how do you convert between metric units? Before we get started, make sure you have your unit conversion table handy, and let's go. Before we learn how to do metric conversions, we need to go through a few terms, specifically quantity and unit. So quantity is something that has magnitude and size. Volume, mass, you can think of mass as weight, and length or distance are all quantities. And when we're talking about quantity, we're talking about the number you get from a measurement. Okay, so for example, 5 pounds. 5 is the quantity. 32 miles. 32 is the quantity. Okay. A unit, on the other hand, is the standard used to measure a quantity. For example, you could measure the quantity mass used with the units pounds, or with the unit grams, or with the unit ounces. Okay, so if we go back to my previous example, 5 pounds. 5 is the quantity. We weighed it on a scale. The standard we used was pounds. Pounds is the unit. All right, so now let's learn how to do metric conversions. When doing unit conversions, you can use your conversion table. And today, since we're doing metric conversions, you'll be using the metric conversion portion of your unit conversion table, which is the top, maybe third, and it's titled metric conversions. Okay, so make sure you can find that area before moving on. Let's take a moment to talk about how the metric conversion table is set up. Right, metric units come in two parts. You've got a prefix, which is written before, and you have a base. So let's start with the second part, the base. The base is the unit you're using without a prefix. Examples that we use a lot in chemistry are gram, liter, meter, second. However, I want you to be aware that a base could be any unit without a prefix. It could be things like pascals or joules or tons or hours or elephants or whatever. Okay, it's any unit without a prefix. All right, so you'd find the base on the table in about the middle there, and you would use that location if you have a unit with no prefix. Okay, so what would that look like? It would be a single word. For example, gram, or a single abbreviation letter. So, for example, G. Okay, now let's talk about the prefixes. Prefixes can also be found on the metric conversion table, and it's the top two rows here. So if we look at this on the far left, we have the prefix tera, which has an abbreviation of capital T. The far right, we have the prefix pico, which has the abbreviation little p. Let's try writing a few metric units. Let's say I had this and this, the two green things. The prefix is written first, so it would be written as mega, and then the base is grams, megagrams. We could also write it in abbreviated form, which would be capital M for mega and lowercase g for grams. Let's try one more. We've got something in the liters area. Okay, so we could write that as milliliters, or we could write it as abbreviated small m for milli and small m, try that again, capital L for liters, milliliters. Those both say milliliters. All right, we are ready to learn how to do metric conversions. So the next part of the lecture is the steps for metric conversions. The stuff written in green down below, 6.25 cm to km, that's going to be our practice problem. All right, so the first step is to find the prefix for your known on the data table. Before we do that, let's identify in our problem where the prefix and the bases are. So prefix, I'll underline in pink the prefix in our problem. Remember, it's always written first, so it's going to be the C and the K. The base is written second, and that will be the M and the M. You'll note that the base is the same. It's the prefixes that change. When you're doing metric conversions, you cannot convert between bases. You can only convert between prefixes. All right, so once again, the first step is to find the prefix for your known on the data table. And it's the CM that we know about because there's a number with it. And we're trying to get to KM. So our known is 6.25 CM. So that prefix is the centi. So it's located right there. Okay, the next step is to find the prefix for your unknown in the data table, so the thing you're trying to convert to. And so we're looking for the prefix kilo, or kili, which is right there. And the third step is to count the number of spaces your finger would need to move to get from the known prefix, which was the orange one, to the unknown prefix. Okay, so we're going to start with the orange one, the centi. How many times do I need to move my finger? 1, 2, 3, 4, 5. I had to move it 5 spaces. And which direction did I go? I went from right to left. Okay, now we're going to move the decimal the same number of spaces and the same direction your finger moved. So if we go back to our problem, I'm going to write it down here. I had 6.25. So I need to move the decimal how many times? 5 times to the left. 1, 2, 3, 4, 5. So the decimal is now there with 4 zeros in front of it. So our new answer is going to be 0.0000625, and the new unit is now kilometers or kilometers. Okay, that's actually it for how you can do metric conversions. But I want to make a really important point here, right down here at the bottom. We did move the decimal, which might feel like scientific notation. But in this case, we're not adding a times 10 exponent, because when we're moving the decimal, what we're changing is the unit. Okay, so keep that in mind. This is not the same thing as scientific notation. Okay. It's now time to check your understanding of metric conversions. If you don't think you feel good about this yet, why don't you go ahead and rewind, rewatch, and if you feel pretty good about it, why don't you try the problems. I'm going to ask today that you please put your answers in both standard and scientific notation. So go ahead and hit pause, go ahead and do the problems, and then hit play, and we'll go over them together. All right, from number 1, we're trying to convert from 3.48 kilometers, or the kilo, to funky looking U meters. All right, let's try to find those on our metric conversion table. So here's kilo, the K, and the funky looking U thing is actually, in case you're wondering, a Greek letter mu, and it's located right there. All right, so now we need to count how many spaces we need to jump to get from what we know, which is the kilo, to what we're trying to find out, which is the micro. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces. All right, so we have 3.48 to begin with, and we'll move the decimal 9 spaces. And we're going to go to the right, because that's the way we went to get from what we knew to what we don't know. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're now going to have something like that. So let's rewrite that so we can actually read it. we have 348 with 7 zeros after it. And that is, oh wait. We cannot forget to write our new unit, which is now micrometers. And that is our standard notation. All right, and let's now try scientific. So if you remember with scientific notation, we need to take our number and make it look like a number between 1 and 9. So we'll end up having 3.48. And then we need to check how many times we needed to move the decimal to get to that point. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our exponent is going to be 9. And it's going to be a positive number, a positive exponent, because our original number was a big number, 1 or bigger. Okay, and this is scientific notation. And again, I forgot to write the unit. That'll get you in trouble on a quiz. All right, let's get rid of all this stuff so we can read everything. Okay, so there are the two answers for number 1. All right, number 2, we need to convert from the prefix pico to, or picoliters, I suppose, to liters. So let's find those on the unit conversion table. The one we know is the pico. What about liters, the one we're looking for? I don't see a prefix there. Where do you look if there's no prefix? Do you remember? You look at the base, all right? So this time we're going to go from pico to base. Let's count the number of times we have to move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times. So we have 497.6. We have to move 12 times, but this time we're going to go to the left because one we know about is on the right and we're moving to the left. So 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Goodness gracious. So our number is going to look like 9 zeros, a 4, a 9, a 7, a 6 liters. That is our standard notation. Okay. Now let's try going to scientific notation. Remember, it needs to be one number in front of the decimal. The number needs to be between 1 and 9. So we'll end up with 4.976 times 10 to the, how many times do we need to move the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10 to the 10th. And this number here is a small number, right? It's smaller than 1, so it's going to be, the exponent is going to be a negative 10 liters. And let's clean this up a little bit so we can read our answers. All right, so this is our scientific notation. So those are our two answers for number 2. Okay, last one. This time we're going to go from 18 CS to DS. So let's find those on the unit conversion table. C is centi, and D, well, there's two D's, right? This one's a capital D, so it must be deca. All right, so let's see how many places we need to move from centi to deca. 1, 2, 3. 3 times, and what direction? To the left, from the unknown towards the known. All right, so we have 18, and the invisible decimal is going to be right behind. And we need to move that decimal 3 times to the left. So our answer will be 0.018 decaseconds. And that's our standard notation. Okay, and for scientific notation, again, there needs to be one numeral or one digit before the decimal. So it's going to be 1.8 times 10 to the 1 to the 2. And this number here is smaller than 1, so small number, which means it's negative. So we have 1.8 times 10 to the 2 decaseconds. And that is our scientific notation. All right, there you go. That's it for today.